Hello guys, welcome to my channel. This is Java Data Structures and Algorithms course, and today's topic is implementation of linked queue. If you have not already subscribed to my channel, please subscribe and promote the content. Thank you. Queue basics. This is a linear data structure. This is a FIFO data structure, first in, first out. We use to insert on the one end and remove from the other end of the queue. Normally we delete from the front and insert at the end of the queue. Usage. It is used to manage data flows and tasks in applications. It is used in event simulations like bank queue, ticket queue, and it is also used in various graph-based data structures for various purposes of local storage. Link-based queue complexity. Insertion is O1. That is the best case happens when queue is empty because we are going to insert at the front of the linked queue. On worst and best cases, worst and average cases, as we are inserting at the end of the linked queue. Deletion is O1 in all best, average and worst cases, as we are removing from the front of the linked queue. Peek, view the front element that has the complexity of O1. Search is O1 in best case if the element exists at the front of the queue, otherwise it is On in average and worst cases because of the linear search. Dynamic memory model, as we allocate memory for the n elements, so memory requirements are On. Thank you guys. Let's begin coding. Hello guys, let's code the implementation of linked queue. So I have created a project in Java NetBeans and added 3 classes. The queue class that will implement the linked queue, and the node class that will be used to develop the linked queue, and the test class. This will test the functionality of the queue. So let's begin with the node class. So we are going to implement node class that will maintain data and the link to the next node. So what we need, private, let's say int data, and private node next, data to store, and here we keep the reference to next node. We need a constructor, public node int data, and this data is equal to data, and next will be null because we are not assigning it at the time of instantiation. So when constructor to create a node with the data assigned to the instance field. Okay, next we can create getter and setter methods for these two fields to save time. So we will insert code, select getters and setters, and select both the fields and generate, and over getter and setter methods are generated. Okay, next let's move to queue class. Okay, so here we implement the queue. So we need a reference to the node that will maintain the linked list of queue. So private node, and let's say we name it head. Okay, constructor, public queue, default constructor to set up empty queue. So in the beginning there is nothing to store. So count of elements, private int count. So let's initialize. Head will be initialized to null, and count will be to 0. Okay, now we need to add element. So we will adopt the strategy to insert the element at the end of the queue. So the complexity for the enqueue function will be on or o1 if there is no element within the queue. So public enqueue int data enqueue at the end of the queue. Remove function public int dequeue, and this will do the opposite of our enqueue. Remove from the front and return it. So its complexity will always be on. Let me write it on. Sorry, o1, because we are remove from front and return. Simple. Front element. So its complexity is on for any insertion, and o1 if the queue is empty. Okay, next, peak int peak. So this function we will use to check the front element of the queue. So its complexity will always be o1, front element. Okay, next, public int size, return count, get the number of elements within the queue. So complexity will be o1, size of queue. Next is empty, public boolean is empty. The complexity will be check the queue is empty or not, and complexity will be o1 always. Indicate queue is empty, and return head is equal to null, boolean. Okay, now print function, public void print, display the queue complexity o1 best case and on average and worst cases for the number of elements. So first we check if this dot is empty. So we simply display the queue is empty and return from here. Now node current is equal to head. So let's print it, %d and current dot get data, and here we print f. Move to the next node, get next. Now loop till the end of the current is not equal to null, till the end of the queue. So we print, let's copy this and we change it a little bit to make a better output. Okay, and move to the next, dot get next. Okay, that's it. Here we will output s out and close it. So this will print the list, and this will print the queue. Now Let's move to our main two functions and peak. Okay, peak function. If this dot is empty, we return null. Otherwise, we return head dot get data. Null. Okay, let's say -9 or any arbitrary, let's say integer dot max value, just an arbitrary value to indicate this is empty list. Okay, now the enqueue function. Insert at the end of the queue. Okay, case 1. So if this dot is empty, let's create the node first. Node is equal to new node and data. Okay, if it is empty, we store it to the head. That's it. Otherwise, we move to the end of the list. Sorry, queue, because we insert at the end and we remove from the front. Okay, to do this, we need to navigate. So node current is equal to head, and while current dot get next is not equal to null, we move current is equal to current dot get next. Okay, we reached at the end of the list, so we just set the new node to the next node of the last one. Current dot set next is equal to node. That's it guys. We are done here, and here we increase the count. Very simple enqueue function. Insert at the end of the queue. So if we reach here, it is O(n) complexity. If we reach into the else block, its complexity is O(n), because n is the number of elements or nodes within the queue that we have to navigate to insert at the end of the queue. Okay, this is further simple function. Check empty. If this dot is empty, so what we will do, return a arbitrary number, integer dot max value, and do nothing. We can also print, let's say s out queue is empty. Okay, here we remove the first node from the queue. So what we will do, store the data, and data is equal to head dot get data. Okay, and store the next node to the head dot get next. That's it. And reduce size and return the value. That's it guys. Very simple dequeue function. Here when list is empty, queue is empty, here again it is O(1), because we are only removing one element that is at the front of the queue, and the complexity is O(1). Okay, let's move to the testing of this queue. So we create object queue is equal to new queue. Okay, it is created. Let's enqueue few numbers. So queue dot enqueue, let's say 2. So over list becomes 2. So print it, queue dot print. Now let's copy this. We are inserting, let's say 9. It will become 2 and 9. 9 goes at the end of the list. Let's insert, let's say 18, and it will become 2, 9 and 18. Again next we are inserting 3, and it becomes 2, 9, 18 and 3. One more element, and let's say 11. So it becomes 2, 9, 18, 3 and 11. Now removal, dequeue. So while not queue dot is empty, we remove the function. So SF, let's say front element removed, %d %n and queue dot dequeue. Okay, now print the list, queue dot print. That's it. It is enough to test the functionality of the. So guys, it is enough to test the functionality of the queue. So let's run it. So let's check the output. Okay, so we inserted 2, it becomes this, like it is here. Then inserted 9, it becomes this one. Then keep on inserting elements and it goes at the end of the list, end of the queue. Okay, so we have 5 elements within the queue. Next, I have used the dequeue function and print the top element and then removed it. So 2 is removed, front element 2 removed, front element 9 removed, and then front element becomes 18 and it is removed. Then 3, it is removed, and the last element is 11. Once it is removed, the list becomes empty. Thank you guys. This is the whole implementation of a simple singly linked list based queue that you can extend to be used in any data driven or event driven applications. And thank you for watching my video, and please, if you have not already subscribed to my channel, please subscribe and promote the content. Thank you very much and have a very good day, and see you in the next video.